Okay, morning guys. So today we are going to look at part 2 of the ear and hearing. So this is factors affecting hearing and ultrasonic sounds. Your keywords are loudness, ear defenders, frequency and hearing range, though we might add some more keywords to the list as we progress through the lesson. Depends on which ones come up in the lesson. So, your learning objectives. Define and understand the term hearing range, describe factors which affect hearing and explain how to prevent damage to the ears, and evaluate how we can find out about sounds that we cannot hear ourselves. And again, we have this little cartoon here with the aeroplane in the background and these two completely oblivious as to this aeroplane coming towards them. Okay, so let's have a think about this. So if a mouse makes a noise at 12,000 Hz, what frequency would you expect its predator to be able to hear and why? And then think about this question. So why might the mouse also make noises at 24,000 Hz? So pause this video here, have a think about those questions and come back when you are done. So let's think about the first question first. So if a mouse makes noises at 12,000 Hz, what frequency do you expect its predator to be able to hear and why? So you'd probably expect the predator to be able to hear 12,000 Hz so that it can detect its prey and it can track it. And why might the mouse also make noises at 24,000 Hz? Well, if the predator can detect 12,000 Hz and is in tune to that one, 24 will probably be above the hearing range of the predator. So making noises at this frequency will allow it not to be detected by the predator. So it can escape notice of its predator. So it can therefore survive and live longer. Okay, so let's go on hearing ranges now. So the frequency of a wave is the number of waves per second, as you know from previous lessons. It's measured in hertz, again, as you know from previous lessons. And if a sound wave has a higher frequency, it means that more vibrations arrive per second and it sounds higher pitched. So a high frequency is high pitched, remember that. So we can only hear things at certain frequencies, only hear sounds at certain frequencies, and the sounds that we can hear from the lowest to the highest frequency is our hearing range. This differs widely from animal to animal. Many animals can hear sounds so high-pitched or so low-pitched that we cannot hear them ourselves. And for example, this bush baby here has a hearing range of 92 Hz to 65 kilohertz. So 1 kilohertz is 10,000 Hz, to put that into perspective. Okay, so, and you can see he's got a nice tasty grasshopper, I think he's got there. So here we have a diagram comparing humans, which are here, with other animals. So we can see that the bat has a range from 10 to just over 100,000. So that is a wider range than us because they can hear below us and above us. The cat can hear above us and so can the dog. And the cat can't hear below us, so we can hear below the cat, but the dog can hear very similar. I think it's the same there for the lower limit. The dolphin can hear above us, but we can hear below what the dolphin can. And the grasshopper has a very narrow range, so that falls in between our range of hearing here. So, what range of frequencies can be heard by all of the animals in this figure here? Have a think about that. Write down an answer and then we will discuss it. Okay, so if we're looking at all the animals, so the grasshopper slightly overlaps this one. So you would have to go along here and it'd be around there. So that is around 300 Hertz. So 300 Hertz to 1000 Hertz, everyone can hear that on this diagram. So that is the answer to that question. And if you're going for the entire range of this graph, it would be 10 to 100,000, or just over 100,000. Okay, so human hearing range. So humans can hear sounds with a frequency of 20 Hz up to 20 kilohertz. And as I said, 1 kilohertz is 1000 Hz. So that means 5 kilohertz is 5000 Hz and 10 kilohertz is 10,000 Hz. And the human ear is only able to withstand sounds of a certain loudness. If it is too loud, and our ears can be permanently damaged. And some causes of ear damage and hearing loss can be treated, however. So here are some causes and solutions. So the ear canal can be blocked with wax. So a solution, you can have it cleared out by a doctor. They can basically use a solution which will help cleanse your ear and wash it out. Very loud sounds can rupture the eardrum. A solution, the eardrum may heal itself, but that takes a long period of time. The eardrum can be damaged by infection. You can use antibiotics to get rid of the infection. Ossicles can become fused together, so an operation is needed for this. An infection may occur in the middle ear. You can use antibiotics again to get rid of the infection. Hair cells and nerves in the cochlea may be damaged by loud noises. There is no cure for that, so you will have permanent hearing loss there. And in older people, nerve cells may deteriorate, and again, there's no cure for that. So you will have hearing loss if you have these two here. So preventing hearing damage then. So there's a lot of things there about what can happen to it, but you can prevent hearing damage. So you can turn down the volume of sound-making devices. So you'll notice on many phones, you'll have a maximum limit that you can have on headphones. And above that limit, it will warn you. So it will put up a little warning to say this is too high, or beware of this frequency because it can damage your hearing. So pay attention to that. You can increase the distance from the source of the noise and yourself. So if you're further away from a noise, then that's less damaging than being right next to the noise. You can reduce the time of exposure to loud sounds, or you can wear ear defenders. Ear defenders are really overlooked, really. A lot of people think that they are just for kids, but anyone can wear them. If you want to protect your ears, because you've only got one pair of ears to last your lifetime, you can have surgery to repair some hearing, but you wouldn't get your original hearing back in most cases. And also you can obey the laws that limit noise in the workplace. So that is important for employers to follow. And also these ones here, and they can provide ear defenders to their workers. And you can use soundproofing materials. So let's test your understanding. So we've got a match the statement about ear damage to the correct solutions task here. I'd expect all of you to be able to attempt that, please. All of you should be able to attempt the red question as well. So we have, what is human hearing range? Why is it important to protect your ears? Draw two diagrams to show what is meant by wave frequency. So that is a link to a previous lesson. And imagine this, you are the manager of a new quarry which will blast stone from a rock face. Explain what measures you will take to protect the hearing of your workers. So we've got 4 questions and a task here, so take 5 to 10 minutes to complete this task. Try your best on these questions. You can bullet point answers. Just list them. That's all you would need to do in the exam anyway, just to make sure you have points down. And then we'll go through the answers in a moment. So pause the video here and then come back when you are finished. Okay, so you're matching the statements here. So the ossicles become fused together, so an operation is needed for that. Hair cells and nerve cells in the cochlea are damaged by loud noises. There is no known cure. The ear canal becomes blocked with wax. You can have the ear canal cleaned out by a doctor. Infection occurs in the middle ear. You can use antibiotics to get rid of the infection. And very loud sounds damage the eardrum. So you can have, the eardrum heals itself over a long period of time. That is what you should have got for that task. Okay, so the human hearing range, that's 20 to 20,000 hertz. Why is it important to protect your ears? To avoid the ears being damaged by loud sounds. Remember, you only have one pair of ears. It's like you only have one set of teeth when you get older. So you have your milk teeth and you have your adult teeth. It's the same concept. So draw 2 diagrams. So you should have one diagram that shows many waves of a short wavelength and one showing a few waves with a longer wavelength. And imagine this. You are the manager of a new quarry which will blast stone from a rock face. explain what measures you will take to protect the hearing of your workers. So you can provide hearing protection, such as ear defenders, increase the distance between the noise and the workers, obey the laws about noise, and also follow the other regulations that employers have to follow by law. So, sounds that we cannot hear then. So you've got infrasound, that is a sound at frequencies below our hearing range. So our hearing range is 20 to 20,000, so it is sounds below 20 hertz that we cannot hear that are infrasound. That is another keyword that I'm going to introduce here. So infrasound, then you've got ultrasound, so that's another keyword. So sounds at frequencies above our hearing range, so sounds above 20,000 hertz. So here you go. So you've got your lower limit here, that's 20,000 hertz. Then your upper limit is 20 hertz, and then your upper limit is 20,000 hertz. So this is our hearing range here, and then we've got this bit here, that is the infrasound, and then this part here is your ultrasound, because you cannot hear it and you cannot hear this bit here. So bats, whales and dolphins use ultrasound when locating prey through echolocation. You've touched on this briefly before. So here you've got the bat. So the bat will emit waves of sonar, and that's what it is, ultrasound waves. And here's the prey. So the waves then bounce off the prey and they go back to the bat. So the bat knows which direction to go in to get its prey. So uses of ultrasound. So we can use in medical devices. So medical devices can produce ultrasounds. We can use ultrasound to safely scan body organs and unborn babies. So we have an image here of an ultrasound image of a baby, which you would go for when you're pregnant, and that allows checks for anything unusual. Metal in aircraft parts and underground power pipes can be scanned for cracks using ultrasound, and sonar can be used to send through water and detect reflection from objects. So a lot of fishing companies and fishing boats will use sonar to detect new swarms of fish so that they can go and catch them. So that is an example there. Submarines also use echolocation as an example. So other uses, the high frequency means that they transfer energy rapidly. Kidney stones can be broken up by using an ultrasound without the need for surgery because of the high frequency. And you can use, this is a small jewelry cleaner, which is an ultrasonic jewelry cleaner. You can use ultrasound to clean surgical equipment, electronic components, machinery, jewelry, and teeth. You can clean those all safely with ultrasound. So let's go on infrasound. So infrasound waves transfer little energy, but they can be detected by microphones. Some large animals use infrasound waves to communicate. Scientists can detect these waves to track herds in conservation and protection projects. And scientists can detect infrasound from volcanoes that are about to erupt, and so warn people of the impending risk. So that is when you get the Richter scale. That is an infrasound. So we cannot hear it ourselves, but we can use machineries to pick up on the sound and warn people before an earthquake or a volcano occurs. Infrasound can also be used to track the passage of meteors in space, so we can prepare for any probable collision. Okay, so have a think about this. So here is a ultrasound image of a baby. So explain why and how ultrasound is used to create an image of a baby. Use these sentence starters to structure your answer. So ultrasound is, the wave is emitted onto the woman's uterus, and it is better to use ultrasound than x-rays because. Pause the video here and then we'll go through the answers, and then that is you done for the day. So ultrasound is a sound with a frequency of above 20,000 hertz, which is above the top frequency of the human hearing range. The wave is emitted onto the woman's uterus and will reflect off the baby and be detected by a machine, creating an image. It is better to use ultrasound than X-rays because it is safer and there is no risk of cancer or harming the fetus.